And this is BBC One. Now Patrick Moore with The Sky at Night.
Good evening. In ancient times, the stars were divided up into patterns or constellations, and every civilization had its own set. The Chinese had one set, the Egyptians had another. And of course, the stars and the constellation are not really associated with each other, so constellation patterns mean nothing, and take what patterns you like. We use those left for us by the Greeks. Ptolemy of Alexandria, the last good astronomer of ancient times, who died about AD 180, listed 48 constellations, and we still use those, though others have been added since. Orion, the hunter with his belt and his gleaming sword, the archer, the scorpion, and so on. And if you were asked to name one particular constellation, what would it be? Orion, the Southern Cross, or the scorpion? No. I think you almost certainly name Ursa Major, the Great Bear, or Plough. In fact, there are two bears, Ursa Major, the Great Bear, and Ursa Minor, the Little Bear. Ursa Minor contains Polaris, the pole star, so it's always high up, altitude over 50 degrees here. And the Great Bear is so near the Little Bear that over Britain it never sets. So whenever the sky is dark and clear, you can always find the bears somewhere or other. There's a legend about the bears. It's said that Callisto, daughter of the king of Arcadia, was so lovely, her beauty surpassed that of Juno, wife of Zeus, king of the gods, and that didn't please Juno at all, so in jealousy, ill-naturedly, she turned Callisto into a bear. Years later, Arcas, Callisto's son, was out hunting and saw the bear, and not realizing what it was about to shoot it, when Zeus intervened. He leant down from Olympus, turned Arcas into a bear also, caught both animals by their tails, and swung them up into the sky, where you can now see them. And that's why both bears have long and decidedly unassigned tails. Why can they always be seen from here? Well, the Earth spins round once in 24 hours, and northward, the axis points to a point called the North Celestial Pole, very close to Polaris. That's why Polaris seems to be almost still, and the entire sky goes round it once in 24 hours. You can photograph this easily. On a clear, dark night, point your camera toward Polaris and give a time exposure. You find the stars are drawn out into trails, and the further away they are from the pole, the longer the trails. And over Britain, the Great Bear never sets. But now look at Arcturus, which is further away, and for part of its circuit, it does go below the horizon, and you can't see it. I may say, there's no bright star near the south celestial pole, though of course you can photograph southern star trails. Polaris hasn't always marked the north celestial pole. As the Earth spins, it wobbles or precesses rather than the way of a boy's gyroscope that's running down. Well, a gyroscope does it in a few seconds. The Earth's precession takes 25,000 years. Therefore, the position of the pole slowly changes. When the Egyptian pyramids were built, the pole star wasn't Polaris, but Thuban in the constellation of the Dragon. But Thuban isn't as bright as the pole star. In fact, Polaris will be closer to the pole in the year 2100, and after that the pole will move slowly away again, and in 12,000 years' time, our North Pole star will be the brilliant blue Vega in Lyra. Now let's look at the bears themselves, starting with Ursa Major, the Great Bear. The seven main stars make up the pattern known often as the Plough, or in America as the Big Dipper. They're not particularly bright, but they're very, very easy to find. They've all got names: Diope, Merak, Pad, Megwez, Alioth, Mizar-Alcor, and also they have Greek letters like all constellations, from Alpha down to Eta. Two of them, Merak and Diope, are known as the pointers. They show the way to Polaris, the pole star. And now look at the stars individually. 6 are white, and the seventh one, Diope, is decidedly orange, so its surface is cooler. And binoculars bring that out very well. Try it and see. Of the 7 Plough stars, one, Megrez or Delta Ursae Majoris, is much fainter than the rest. It's been claimed that 2,000 years ago it was equal to the others and has faded. But frankly, I doubt that. It's not that kind of star. A man can't trust those old records too far. We tend to think of constellations as being fixed. That's not strictly true. It's just that the stars are so far away that their individual or proper motions are very slight indeed, but they can be measured. And we now know that at the Plough, 5 stars are going one way, and the other 2, Alcor and Dupe, in the other direction. Therefore, over a sufficient period, the pattern's going to change. Come back in 50,000 years, and you'll see what I mean. The 7 stars are not equally distant. We are dealing only with line of sight effects. According to the Cambridge catalogue, which is as good as any, Alcor is over 100 light years away, and the rest below 80. But what about a light year? Now, the stars are so far away that to measure this in miles would be rather awkward. Therefore, we use the light year. Light travels at 186,000 miles per second. Therefore, in 1 year, it covers nearly 6 million miles, and that's what we call the light year. Also, the stars are not equally powerful. Alcor is over 400 times brighter than our Sun. Megrez only 17 times, so appearances can be deceptive. And a star may look bright, either because it's really very luminous, or because it's fairly close, or a combination of both. Mizar, or Zeta Ursa Major, is of special interest. It's 59 light years away, and close beside it is a much fainter star called Alcor. It's often known as Jack and his Rider. There's a minor mystery here. The Arabs, about 1,000 years ago, said that Alcor was a difficult naked eye test, and it certainly isn't so now, but I'm sure there's been no real change. Now, use the telescope and look at Mizar. See Mizar and Alcor, and you'll see Mizar itself is made up of 2 components, one rather brighter than the other. The brighter Mizar is 56 sun power, and the fainter one is 11 times as powerful as the Sun. Now, they make up a genuine or binary system, and they're going around their common centre of gravity, rather as the 2 bells of a dumbbell would do when you twist them by their joining bar. But they are a very long way apart, and therefore the revolution period amounts to thousands of years. And that's not all. Using spectroscopes, we can find that the brighter member of the pair is itself a close binary. This time, separation only 18 million miles, and revolution period 20 days. And with ordinary telescopes, that looks like a single star. Quite a family party, though. And that's not all. Use a telescope, and you see that between the Mizar pair and Alcor, there's a much fainter star, known as Ludwig star, after the Landgrave of Hesse, first noted, I think, in 1681. But that is not a genuine member of the group. We're dealing again with line of sight effects, and Ludwig star is much further away and lies in the background, not connected with Mizar at all. Again, appearances can be highly deceptive. The Plough is only part of the larger constellation of Ursa Major, and there are various other interesting objects. Here's a nice little binary star, Xi Ursa Majoris. Components fairly equal, period 60 years. Actually, the very first binary to have its orbit worked out. And then, what about a nice red variable star? Here's one, Z Ursa Majoris, an unstable star, swells and shrinks, and period roughly 200 days. And you'll find it easily, sweep with binoculars, and the colour makes it stand out at once. You can't see it with the naked eye, but binoculars show it easily. And then, what about galaxies? There are several in Ursa Major. It'll be M81 and M82. Now, why M? M stands for Messier. Way back in the year 1781, the French astronomer, Charles Messier, made a catalogue of over 100 star clusters and nebulae, because he was a comet hunter and kept on confusing nebulae with comets. And we still use the Messier numbers. So M81 and M82 are the 81st and 82nd entries. M81 is a spiral galaxy, 8.5 million light years away. Its neighbour, M82, is irregular and is a strong radio source. Look for them, the other star, 24 Ursa Majoris. M81 is fairly easy to see with binoculars. It's said that M82 can be seen with binoculars. Frankly, I've never managed that. Others may do better. And those 2 galaxies really are neighbours, and they're having actions upon each other. Just outside Ursa Major, in the hunting dogs near Alcor, is the lovely Whirlpool galaxy, M51, a face-on spiral 37 million light years away. I may say that was the first spiral to be recognized as such by the Earl of Ross way back in 1845 with his home-made 72-inch telescope in Ireland. And he who gave it his nickname, you can understand why. Another Messier object is M97 near Merak, the fainter pointer. It's known as the Owl Nebula, and you can see why. It's what's called a planetary nebula. That's rather a bad term. It's not really a nebula, and has nothing at all to do with a planet. It's a misleading name. It's a very old star that's thrown away its outer layers, and it's 10,000 light years away from us. Most stars go through a planetary nebula stage at one point in their careers, and our sun will do so. In several thousands of millions of years, our sun will turn into a planetary nebula before collapsing into a very dim, faint white dwarf. Frankly, I find the owl rather elusive. If you want to see a better one, then look for M57, the ring nebula, in the constellation of Lyra, near the brilliant blue Vega, slap between Beta and Gamma Lyrae, and that's very easy to find. Again, people say you can see with binoculars. I can't. A small telescope will do. Before leaving the Great Bear, let us seek out Messier 101, which makes a triangle with Mizar and Alcor. This is a face-on spiral between 11 and 12 million light-years away. It's beautifully displayed. It is smaller and less massive than our own galaxy, and therefore it's rather faint. And incidentally, several supernovae have been seen in it. All in all, Ursa Major has a great deal to attract us, but it's nowhere near the ecliptic, and therefore no planets go through it. Also, it's nowhere near the Milky Way. Our galaxy is a flattened system, rather like two fried eggs clapped together back to back. Look along the main plane, we see many stars in the same direction, and that causes the Milky Way, and Ursa Major is nowhere near that, therefore it's not so rich in very faint stars. There's one star, though, 47 Ursa Majoris, of special interest. We now know it's attended by a planet. The star itself is of the 5th magnitude, close to the little triangle made of Xi, Lambda, and mu Ursa Majoris. Incidentally, use binoculars and look at those three. You'll find there's a color contrast there. Lambda's white, and mu is fiery red. Now, 47 Ursa Majoris is 42 light-years away, rather more luminous than our sun, and the planet going around it is roughly 2.5 times the mass of Jupiter, 200 million miles away from the star, with an orbital period of just over 1,000 days. And it must really be a gas giant, more like Jupiter than like the Earth, but a very strange kind of world. Now let's pass on to Ursa Minor, the little bear, which by sheer chance is rather like a faint and distorted version of the Great Bear. There are only 2 stars as bright as the 2nd magnitude, Polaris itself, and the obviously orange Comet, or Beta Ursa Minoris. Then comes Fircad, below magnitude 3. And the other stars in the little plough are very much fainter, so any mist will drown them, and in a light-polluted area, you won't see them at all. You only see the 3 main stars. Polaris is 680 light-years away, and therefore we see it now as it used to be in the time of the Crusades. It is 6,000 times as luminous as our sun, and is very slightly variable. In fact, it used to be more variable than it is now, and for a time, astronomers thought it might stop changing altogether. It's not done that, but the changes in brightness are so slight you can't notice them at all with the naked eye. Polaris has a companion, magnitude 9. You can see it with a 3-inch telescope, but not with binoculars. And it really is genuinely associated, but it's a long, long way away from Polaris, and the orbital period must be many thousands of years. I must say Polaris is said to be slightly yellowish, but to me it always looks white. The other bright star in Ursa Minor is Comet, or Beta Ursa Minoris, which is quite clearly orange in color. Much closer than Polaris, only 95 light-years away, and just over 100 times as powerful as our sun. It and its neighbor, Gamma or Fircad, are often known as the guardians of the pole. There are no special points about the other stars of the Little Bear, and no bright clusters or nebulae, though there are 1 or 2 red variable stars which can rise to binocular visibility. Remember I mentioned the former pole star, Thuban? Well, here it is in the long, winding constellation of the Dragon. It's 230 light-years away and 130 times as powerful as our sun. It's rather isolated and has no particular special features about it. Ursa Major is invaluable for finding your way around the sky. And of course, over Britain, it never sets. It's circumpolar. We've found the pole star. Now come back to the bear and follow round the tail. And you'll come to the brilliant orange star, Arcturus, in blue it is the herdsman, actually the brightest star in the northern part of the sky. And not far from there, a little semicircle of stars marking Corona, the northern crown. You can't mistake Arcturus, it's so bright and a lovely light orange colour. If you follow that still further, you will come to Spica in Virgo, the Virgin, a bright white star, not so bright as Arcturus, but still first magnitude. And Virgo itself is rather Y-shaped, and the star at the junction of the Y, this one called Gamma Virginis, interesting. With the naked eye, it appears as a single star. Actually, it's a binary, and telescope shows it's made up of two equal components. Back to the bear. This time, let's use the pointers the wrong way. That's to say, away from the pole star, and you'll come fairly near Regulus in Leo the Lion, one of the zodiacal constellations, known as the Royal Star. And extending away from Regulus is a curved line of stars, marking the famous sickle of Leo. And this one, Gamma Algebra, is also a nice double star. And then, also from the bear, we can find something else. We can find the twins, Castor and Pollux, using Maigret and Dupay. Not very accurate, I fear, but if you extend it far enough, then you'll come to the twins. And note of those two, Pollux is the brighter. And they're a bit different too. Pollux, an ordinary orange star. Castor looks single. Actually, it's a whole stellar family. A small telescope shows there are two main components, and each of those is itself a very close binary. And there's another companion, which is also a close binary. So really, Castor is made up of a whole family of stars, 4 bright and 2 dim. Well, I hope on the next clear night you'll go out and find Ursa Major and Ursa Minor. They're not particularly brilliant, not so brilliant as Orion or the Scorpion, but there's plenty there to interest you. And of course, from here, they're always on view. Go south of the equator, and Polaris can't be seen. And you know, a little while ago, I was down in the South Island of New Zealand. A lovely sky, the Southern Cross, the ship, the Centaur, the Milky Way, but no bears. From there, even the great bear never rises above the horizon. And I found that rather sad, because to me, you know, I'm so used to them, and the sky looks very barren without our two familiar bears. Don't forget our website, www.bbc.co.uk/space, or CFAX page 620. Now for a quick news note. We have a comet, a Keia Zhang, and here are photographs of it sent to us by Martin Mobley. As you can see, the head and quite a respectable tail. It's no hail bop, the best comet for some time. It's now in the constellation of Pisces, rather low in the west, and it will get higher and brighten as the months go through, and certainly the nucleus may finally be about as bright as the pole star, so it's a very respectable comet. It's periodic, and it may well be identical with the comet seen in 1611 that's always being worked out now. So look out for this comet, make the most of it. It won't be back for several centuries. And remember, there's always something new to see. The skies are always changing. Until next month, good night.